The sky is never immutable, and even though we are accustomed to see the same figures, the same constellations, day after day, year after year, the sky is not the same. The positions of the stars in the sky change, and the sky we see today is not the sky ancient Egyptians saw. The precession of the equinoxes, or lunisolar precession, is the main reason for this change, and it is of fundamental importance to take into account when talking about astronomy and history. Because of precession, the coordinates of the stars change with time, and also the positions of the constellations in the sky, with their consequent cultural meaning. As the name suggests, the lunisolar precession is due to the gravitational pull of the Sun and the Moon on the Earth axis. The Earth rotation axis is inclined of around 23 degrees with respect to the vertical to the ecliptic. The Earth has a slightly oblong shape. As a consequence, the gravitational pull, primarily of the Sun but also of the Moon, acts with a different intensity on the regions of the Earth that are closest. The combined effect is a rotation of the rotation axis around the vertical to the orbit. The tip of the Earth axis describes a circle, which we can imagine as the basis of a cone with the tip at the center of the Earth. Since the direction of the Earth axis indicates the celestial north, the rotation of the axis implies a shift of the celestial north in the sky. The shift happens over millennia, completing a full cycle in about 26,000 years. This means that currently the celestial north is indicated by Polaris, the brightest star of the constellation of the Ursa Minor, the closest star of appreciable luminosity to the celestial north. But in the past, for example at the time of ancient Egyptians, the North Star was Tuban, alpha star of the constellation Draco, the dragon. In the future, Deneb, Alpha Cygni, in the constellations of the Swan, will take Polaris' place. But where does the name precession of the equinoxes come from? It comes from the constellation projected at the east the day of the spring equinox, and therefore the backdrop of the Sun's apparent motion during that moment of the year. The point of the vernal equinox in the sky is the intersection between the ecliptic and the celestial equator, and corresponds to the sunrise at the spring equinox. The rotation of the Earth axis implies a variation of the inclination of the celestial equator, and a shift of the vernal point with respect to the fixed stars. So it happens that the vernal equinox crosses all the zodiacal constellations during the full precession cycle, and the constellation corresponding to the position of the Sun on the spring equinox gives the name to an era of roughly 2,000 years. Our current epoch is the one of the Pisces, and it will be followed by the Aquarius, moving forward towards the west. While the lunisolar precession doesn't vary the inclination of the Earth rotation axis, but only its direction in space, another phenomenon contributes to slight variations of the inclination angle: nutations. They are also due to the gravitational pull of the Sun and the Moon, but this time with a predominance of the Moon attraction and of its inclined orbital plane. Nutations superimpose on the lunisolar precession cycle, causing slight hiccups on the inclination angle of the order of 10 arcseconds over a period of 18.6 years, dictated by the lunar nodal precession. The other planets of the solar system also contributed to a shift in the orientation of the Earth axis, to a lesser degree, making the motion of the Earth axis complicated but predictable.